video is going to walk you through how to handle the problem where you have to graph the functions, graph the system, and also find the intersection points. This particular example, we have a linear equation along with a parabola. And so on this graph, you can see our tools down here. We have our linear equation and our parabola. So graphing negative x plus 1, I expect that we can do that pretty well without a lot of help from our graphing calculator. You have a y-intercept of 1, so you're going to plot a point there, and then need to drag this other point to wherever it's going to be to create our line. Now I look at that slope and it says it is negative 1, so I go to the right one and down one, or down one and to the right, doesn't matter the order. You click to make another point, and there you have your line. For the parabola, however, as you can see down here, these red points, this red point is at the vertex of the parabola, and then another point. So we need to be able to figure out the vertex of this parabola. That's where the graphing calculator comes into play. So you can see I already have my system typed in here, negative x plus 1, x squared plus 2x minus 3. As I hit graph, we see that we have this show up. This blue line is exactly as we think. We're trying to graph this red line. Now as I look at this red line, I already have an idea where my vertex is. My vertex is either at the very bottom or the very top of a parabola. In this case, it's at the bottom. So I have a guess. However, let's know for sure. So we're going to go into my table. That's the easiest way to do it right away. Go into my table, and let's take a look at the red values, because those are the values from the parabola, and I want to find out where the vertex is. If you remember the definition of a vertex, there should be some symmetry, or there will be some symmetry around it. So you have negative 1, 4. Check out this value right here. I have negative 3, 0, 5, 12 above it, and going down from it, negative 3, 0, 5, 12. Well, there's our symmetry, so we know that at this x value, negative 1, and that y value, negative 4, I have my vertex. So that is what I'm going to start with plotting from here. The second point can be any other point on this parabola. So I'm going to start at negative 1, 4, so negative 1, negative 4 rather. So I have that point, and now I got to find another point on my parabola, doesn't matter where, but another point on my parabola that I can plot in order to find the intersections. And so when I take a look at my table again, it looks like I have another point at 0, negative 3. So here's 0, negative 3, and I can plot that, and there I have my parabola. And I mean, you could choose 0, negative 3. You could have chosen 1, 0, 2, 5. Any of those are the points. It doesn't matter in order for you to graph at. And now as you take a look, you also see where your intersection points are. They're pretty clearly indicated here, right, on nice grid points. So I can kind of type those in real quick. So I have the intersection point at 1, 0, and an intersection point at negative 4, comma 5. And those would be your intersections. Now, I also want to talk about how you would find those on your graphing calculator in case they're not quite so easy. We're pretty much done with this question, but let's verify. So let's take a look at my graphing calculator. Still in my table, here I am at 1, 0. We'll check that out. Both y1, my line, and y2, my parabola, have the same y value. That means that's an intersection point. And at negative 4 on the x, they both have a y value of 5. That means that's an intersection point, which is what we have down here. When x is negative 4, they're both 5. When x is 1, both graphs are 0. Okay, so that's how you use your table. Now I want to talk about how to use your graph as a reminder. I can see them on here, but how do we get the calculator to calculate that for us? Easiest way to do it is you hit second, trace, 5, and as you take a look here, your cursor can be anywhere on this graph. It's most likely going to be here at like 0, 1. And so the first question is first curve, and it's my line, so I hit enter. Note this switches automatically to the parabola. That's my second curve, so I hit enter. And then it's going to ask me to guess. Usually we just hit enter right away, and here it tells me 1, 0. There you go, 1, 0, that's one of my intersection points. I want a graphing calculator to find that one. In order to do that, you do the same thing. Second, trace, 5. First curve is my line, yes, hit enter. Second curve is the parabola, yes, I hit enter. But now you need to move this cursor back away from that one intersection point, or else it's just going to give you the same one. You need to get it over towards this other intersection point. Doesn't matter, it can be just somewhere close to it. Now you hit enter, and it gives me my second one. Right? So if you keep getting the same intersection point over and over when you're doing this process, you got to move that cursor closer to your other intersection before you hit your final enter. And there you go, negative 4, 5 with the graphing calculator.